Welcome to DCTP.tv live from the campus party in Berlin. We're going to talk now about a very interesting phenomenon about nanotechnology. And my next guest is Javier Garcia from the University in Alicante in Spain. Welcome to the program.
Thank you.
So, correct me if I'm wrong, but what I find very interesting about nanoparticles and nanotechnology is that you have one material like gold or silver or whatever, and you cut it in very, very, very small pieces, and you don't get new atoms or new molecules, but the properties of the material change radically. You still have the same material, still have gold, but only because you shredded it in so tiny pieces, you have totally different properties. Is that right?
That's absolutely right. We are learning that when we make materials very small, the properties are totally different, and still it's the same compound. It has the same nature.
For example?
A good example could be carbon. Carbon is a very old element. We all know how it looks like. It could be either diamond or coal. But now when we make it very small, we can make it into graphene, for example, which is a single layer of carbon atoms. We can make balls like bulky balls, C60, or we can make also nanotubes. You see, all the time it's still carbon. It's the same material, so it's the same nature.
Molecule is the same.
Yeah, but the structure is different. And I think that's what is answering your question. It's not really the nature of the material. The fact that carbon has 6 protons in the nucleus, atomic number 6, that makes carbon. But then how the atoms are arranged, the structure of the material is what dictate properties. And that's why if you have many layers of graphene, you have graphite, and it's very different from having only one layer, which is graphene, which is transparent, is conductive, is flexible. We have been talking about touch screens for those kind of materials. You see, totally different from graphite.
Can you give some other examples how properties change when you cut material down to the nano level?
Another good example is gold. So we are all used to the color of gold, golden color, but we can make gold red, for example. When you make very small particles of gold, it becomes red. And actually, this is one of the first applications of nanotechnology. In the Gothic cathedrals, the red we see in the stained glasses actually is made of tiny particles of gold, because people already in the Middle Ages, they knew how to make these nanoparticles. They didn't know that they were nanoparticles, but nanotechnology is actually a pretty old technology. We're just rediscovering it and actually understanding it.
And, I mean, if you want to use a certain property of a certain nanoparticle, you have to determine and intentionally produce a certain structure.
Yes.
It's not only by, oh, I just smash it and cut it out. How do you get the structure you want?
Yeah, there are two main strategies. One is called top-down. That's the one I think you were talking about, just chopping things into smaller and smaller pieces, but it's a limit what you can do there. You can also use microscopes. For example, the tip of some microscope allow you to almost write on different surfaces. But I think the most successful way to create new nanomaterials is called bottom-up. Actually, kind of creating the conditions for the nanomaterials to self-assemble and create these new materials. And that's how, for example, these gold nanoparticles are produced, by creating the conditions where they will grow spontaneously, and that's how you can make many of those.
What are those conditions?
Well, it depends for every different material. In the case of gold, and that's why they couldn't do it in the medieval times, it's pretty simple. You dissolve gold in a solution that at that time was called aqua regia, which is nitric acid and hydrochloric acid. Gold will dissolve there. You get a yellow solution, and then you can add just lemon juice and other organic substances to reduce that gold into gold nanoparticles. And under those conditions, just you see the red color to appear from that solution into the nanoparticles.
So, and since you have these new properties, of course there are new business opportunities, new appliances. Some of them have already arrived in our daily life, like I think the sun milk, the sun protection is based on nanotechnology, right? How does it work? basically?
So, yeah, there are some metal oxides like zinc oxide and titanium oxide that are very good at absorbing radiation. So what people are using now is these nanoparticles of these metal oxides into different creams, and then these are sun creams that we can use every day, and those are safe, and now we see them pretty much in every shop.
You did a PhD at the MIT?
I did my postdoc at MIT.
Postdoc at MIT, and you founded a company which is involved in this nanotechnology, and you have developed a certain product. What is the product and how does it work?
So at Rife Technology, we produce advanced catalysts for the chemical industry. Basically what we have found is a way to expand the porosity on the catalyst. So now also large molecules can be catalyzed. You see, 90% of chemical processes today are already catalyzed, because by catalysis we can select the kind of products that we will obtain. But when you are dealing with very large molecules, the pores of the catalyst are very small, and then it's very difficult to control those reactions. We have found a way to actually expand those pores, and now we can do things like oil refining more efficient, or we can do water treatment or gas separation. So nanotechnology is really enabling many industries, and we see that in the patents. Number of patents in nanotechnology is growing exponentially. The number of new companies in nanotechnology is growing exponentially. So I think this is really an emerging technology. We see new businesses every day, and now, as you said, even as a consumers, we see nanomaterials, clothes, sun creams, in medicines very soon. So it's a reality also.
Since those nanoparticles have all kinds of new properties, some of them are very useful. Obviously, you can make nice businesses and nice appliances with it, and it's pretty useful and everybody wants it. But some people are concerned, well, maybe we don't know all of their new properties, and maybe there are some interdependencies or reactions we don't want. And since we don't know how those particles act together with other new nanoparticles we have not invented yet, maybe they further come, and we don't know how they will react together, and maybe there are some dangers, and how do you assess the risks?
I think those concerns are very real. I think everybody in nanotechnology understands that there is some potential damage to our health and the environment. So I think those concerns need to be addressed properly. One of the things we are doing here at the campus party is raising these issues. So now people can talk openly about these issues, and the things that we need is very good studies on this, so we know what's true and what's myth in the potential impacts of nanotechnology in our health. 2, clear regulation with labeling, so people know what they are consuming and the potential impact on their health.
What should be on the label?
And the label needs to be, it contains nanoparticle, it contains material that has been produced in this way, and this is the different safety precautions that you need to be taken. In most cases, because we are already using materials that contains nanoparticles, in most cases these nanoparticles are embedded inside what we call a matrix, for example inside a polymer. So these nanoparticles are not flying around. That will be bad, but they are actually embedded, they are part of a matrix, and because of that it's very difficult to get exposed directly to that. So we obtain the property we want, for example a change in color, so we can get polymers of different colors, but those nanoparticles are never going to reach our cell or the environment.
Okay, so this is the difference you have to make.
For example, there will be a way around that to make sure that those nanoparticles actually not leach to the environment or they don't, affect us directly.
Should there be like some kind of risk assessment before you introduce a new nanoparticle into the market? Should there be some kind of risk assessment and laboratory tests to be done before it might be published?
These things are being done today. There are many papers, many research on the implications of nanomaterials in health. The European Union is also studying nanotechnology from the regulation on the labeling point of view, so this is not new. What I said is that as society we need to be informed, we need to be educated. This is something that is going to be in every shop pretty soon, so we need to know about these things. So this is not just something for the future, this is a reality as a consumers. We need to know about these things.
You mentioned nanoparticles which are embedded in a matrix and
For
are
example.
not very likely to get in contact with our skin and ourselves. But is there an appliance in our daily life where you would say, well, this is a different thing and we might have to rethink how we deal with this particular product?
Well, I think every product needs to go through a process like any other component. So we are sure that it's safe, it's properly regulated, and it's labeled. So at the end of the day, everybody can make a choice on what they want to buy, what they want to use. But I think we need to find a compromise between people getting scared about something which maybe is not that bad, and actually could stop businesses and research, and also not be naive and trying to understand that it's a potential risk, so we address that properly.
Okay. Thank you very much for your time and good luck.
My pleasure, thank you.
Okay, great.